last lesson we looked at the real number system. We likened it to where we live, how you can be in different places once we're in Hopkinsville, but also in Christian County, because one is inside the other. And so we were drawing the analogy between that, how we're living in different places all at the same time, and the real number system. And we said that counting numbers, whole numbers, and then the integers, which are the whole numbers and their opposites or negatives, all of those were within rational numbers. So we need to pin down exactly what a rational and an irrational number is. The real number system is made up of rational or irrational numbers. You cannot be both, and you cannot be neither. So all those numbers fit into one or other of the categories. In our book, the definition is a ratio that a rational number is a ratio of two integers. Well, that's not always very clear to students what exactly that means. So we try and make it a little simpler for them to remember. So the way we look at it is that rational numbers can be made into a fraction. And so this would include any number that can be made into a fraction. Sometimes it's hard to remember which is which, and it gets confusing, but these are very often multiple choice questions that if you can pin these things down, you can really get a quick answer to a question. It may help that you think of a ratio can be shown as a fraction, so when it's got the word ratio and rational, maybe it helps you remember that it's to do with a fraction. First of all, any whole number, counting number, which are in the whole numbers, or the opposites, integers. Any of those can be made into, so our wholes and integers can be made into rational numbers, into fractions. So if we had the number 3, if I was multiplying the number 3 by a fraction, I would make 3 into a fraction by putting it over 1. But that's also true of the negative numbers. So I can put negative 5 over 1. Now the number 0 is a whole number, and it can also be made into a fraction by putting it over any number. Now we cannot divide by 0, but we can divide 0 by something which is 0. So that can be done. And then, of course, anything that is already a fraction is going to be rational. So a half, a negative 2/5, a mixed number and an improper fraction. So 22 over 5 and 1/8. All of these are rational because they're already fractions. Now, there are some decimals that can be fractions too. One of the things that I like students to remember is the decimal equivalent of a fourth, a half, 3/4, a third, and 2/3. So if we think about 1/4, okay, as a decimal, that is 2.25. And this is a terminating. That means it ends. So it's a terminating decimal. And so obviously any terminating decimal can be made into a fraction. It may not be very easy because it may have a lot of decimal places, but it can be turned into a fraction. And then some of our fractions are repeating. If you remember that 1/3, if we divide 1 by 3, we will get 0.333, and it will repeat onwards forever. So a repeating decimal is also rational. Okay? And there's one other class of numbers that we need to look at. If I look at the square numbers, if I square a number, and what I mean is I square a number, which is the same as multiplying that number by itself, I get 1. If I square 2, 2 times 2 is 4. Now, when we take the square root, we're unsquaring it. So the square root of 4 is 2. So some square roots will be rational, but not all. All right? So some square roots will be rational. And in our next section on irrational, I'll show you how to recognize the ones that are not rational. So again, a rational number can be made into a fraction. It may be a whole number, an integer. It may already be a fraction. It may be a terminating or ending decimal or a repeating, and some of the square roots. All of those are rational. Now let's take a look at irrational. If a rational number can be made into a fraction, then irrational cannot. It cannot be made into a fraction. And so there's going to be more of these, but we don't deal with so many. We're dealing mostly with integers and fractions and things like that. But there are many, many irrational numbers. Now, one of the ones that we know is a special number called pi that we use in calculating circumference and area of a circle. Pi is irrational. It never ends. It goes on for millions and millions of decimal places, and the computer's figuring that out now. So the way to recognize an irrational number is that it's going to be pi. It's going to be a decimal that is non-terminating. Remember, I just said that 0.25 is a terminating decimal, and it can be made into a fraction of 1/4. But non-terminating is not enough because 0.33333, 0.11111 repeating, 0.25252525, all of those are repeating, and they can be made into fractions. So it has to be and I underline that a lot because it has to be both of these non-repeating. So spell it right. Non-repeating decimals. Okay, so it's impossible for us to write the whole thing because it never ends, but you would see something like 0.578823, and then it would be shown with ... showing that it goes on forever. Alright, so this tells us it's non-terminating, and then as you can see there are no blocks of numbers or single numbers that repeat. Alright, so that's how it would be shown. Or I might have more. I might have 121.003521778, and it just goes on and on. But once you see these, and you see that it has no repeating, then it is irrational. And it could be negative as well. All right, and then the last type of number is any number that is the square root of any number that's not a perfect square. So we talked a minute ago about 1 squared being 1, 2 squared being 2, 3 squared, or 3 times 3 is, sorry, let me correct that, that's 4, 9. So I have this list of numbers. So the square root of any non-perfect square number Alright, so that means that anything like the square root of, see, 4 is rational, the square root of 4 is rational, the square root of 9, but the square root of 7 would not be. We go from 1 to 4, so the square root of 2 is irrational. And we'll talk more about this because it's a hard class of numbers to remember that these are also irrational. So we have special numbers, the only one of which we know right now is pi, that's used in circles. We have non-terminating and non-repeating decimals. And then we have the square root of any non-perfect square. And those are the irrationals. And hopefully this helps you sort it out. It is something we work on all year in this class, and so it's not something that people grasp right off the bat. But hopefully you will be able to watch this video perhaps over and over and get an idea of how to sort these numbers out. Because you will see questions, and there are often multiple choice questions that says something like, which one of these 4 is not rational? So they're wanting you to find an irrational number. Or they might say, which one of these 4 is rational? And then you look for a rational number. So you have to be careful of the wording of the multiple choice question, and then you have to know how to do these. But it can be a very quickly answered question if you get the concept.